First, I'd like to thank all the presents here and also extend my acknowledgments to this wonderful faculty here that devoted time and energy to put up this course. This is a wonderful topic, in my opinion. This is one approach that we've been working for 5 years. And through these 5 years, we've learned a lot about how to best use the benefits of small aperture optics, the best scenarios that it can be applied. And we will cover pretty much everything related to preoperative evaluation, the best candidate selection, and everything, so you can walk out from this room with a certain feeling that you have this topic covered. So I do have a financial disclosure. I have a license agreement with Morcher, which is the manufacturer of one of the small aperture implants that are currently available. And our course is pretty much divided or organized into the main applications here. So we can use small aperture optics for irregular astigmatism. We can use it to extend depth of focus and treat presbyopia in normal eyes with normal corneas. We can use it in face of iris defects, and also, based on our encouraging results, we are extending these applications even to those cases where we can treat a multifocal IOL dysphotopsia. So we are going to cover the backgrounds, the indications, patient selection, the management of some of the complications, and also present some special cases where this approach has been used. So this is the basic. We know this is not a new concept. This dates back to the 5th century before Christ, where this Chinese philosopher presented it for the first time. This principle is widely used in photography, and here you can see the effect of a small diaphragm here, which is able to extend depth of focus and improve here the visualization of this ruler throughout its extension. This principle was covered by Leonardo da Vinci and also other important philosophers and scientists that studied it. But in ophthalmology, we must give credit to Dr. Peter Choice, who in the 60s presented the first intraocular implant based on this principle. This was an anterior chamber IOL with an embedded pinhole mask, which was manufactured by Rayner. And throughout history, we saw some improvements in the design and other implants or other devices that applied this principle. And in the 90s, Morcher also released this IOL with an embedded pinhole mask. This used to be a PMMA IOL. And later on, we saw the development of the camera corneal inlay, which was developed for the treatment of presbyopia in phakic eyes initially. And but we witnessed a transition to a direction of a posterior chamber IOL, and with the pinhole principle closer to the iris plane. That's what the current trend shows. And these are the current 2 implants that use this principle, and they have some differences. I like to call them implants because the left model, the extra focus, which we are going to cover mostly here during this course, it's not an IOL. Technically, it's a diaphragm. It has no refractive power. It's just a hole or a pinhole with a 1.3 millimeter opening. whereas the AcuFocus is an IOL itself with an embedded pinhole mask. And this class of implants has been gaining momentum. This recent editorial called it the new kids on the block, and it highlighted its benefits in this group of patients, which I totally agree that this is the best indication for the application of small aperture optics, is when we have aberrated corneas. But not only that. So we've been working with this small aperture implant, which was designed for implantation in the ciliary sulcus in a piggyback configuration. This is called the extra focus. It is made of a foldable black hydrophobic acrylic with a larger overall diameter to be safely implanted in the sulcus. And here, when we consider the main indications, we've covered this. It's either directed to irregular astigmatism and high-order aberrations in the cornea, or directed to the treatment of presbyopia. And during these 5 years, we had a large experience of the use of this implant in different scenarios, in post-PK cases, in keratoconus, in post-RK patients, in normal corneas, just for the sake of extending depth of focus, and also some traumatic corneal lacerations. And all this information is gathered in some of those publications that are in the JCRS, so this is a good source to extend the reading here. But in my opinion, the best indication of all is when we have this terrible combination of a aberrated cornea and some sort of iris defect, or an abnormal pupil size, or a pupillopathy of some sort. And here I would like to start with one very interesting case. This is a man who had a terrible knife accident, who ended up with these corneal sutures and a irregular corneal astigmatism. Also, here in the superior nasal quadrant, we see an important iris loss. And after cataract surgery, he couldn't see better than 20/40, even with correction. And furthermore, he said that there was a terrible conflict between both eyes, this eye and the fellow normal eye. And he would prefer to have his cataract back instead of seeing like he is. So we addressed this with this very simple 5-minute procedure. And after that, he reported an amazing improvement in visual quality, and the most importantly, he reported an increase in comfort, in visual comfort. And this conflict between an abnormal eye and a totally normal eye vanished, or at least reduced. And here he achieved the 20/30 J2 uncorrected vision. And here we can see that the implant is both able to neutralize the high-order aberrations, the corneal aberrations, and also provide a depth of focus extension, which causes the ability to see both distance and near with the significant quality. So this is the starting point of the use of small aperture optics, in my opinion. This is the best candidate, those with an irregular cornea and a large pupil. And I'd like to share a second case, which is similar. This is a keratoconus patient who had a terrible result after an anterior chamber phakic IOL implanted in the past. He had an IOP spike in the first day. The lens was removed a few hours after implantation, but the damage was already done. He was left with this terrible iris atrophy and a large pupil. And here, recently, after his cataract surgery, we implanted the extra focus pinholing device in the sulcus. Again, we're trying to keep surgeons here in their comfort zone. This is an interesting approach because it's somewhat simple, quite reliable, and it's very powerful in the adequate scenario in those, the best candidates. And this patient said this is the best he's ever seen with this eye. So he achieved 20/20 J2. This is a mild keratoconus. We're going to see here cases of more severe keratoconus, but this is again the best combination of an aberrated cornea and a large pupil. This is another interesting case, a post-RK case, which had a terrible iris atrophy after the use of oral moxifloxacin. This is a complication of a drug which was already published. It's a rare complication, and this patient was left with a severe bilateral mydriasis and with this terrible cornea. So again, a terrible combination of an aberrated cornea and a large pupil. This is a patient who had a car accident with a corneal laceration and iris loss, who had already been implanted both an IOL inside the capsular bag and also an iris segment, also from Mortier, inside the capsular bag. Although he was doing okay here, he improved a lot with the benefit of the pinhole. And this is one point that we should consider. When we examine patients in the slit lamp, we tend to believe that most pupils are the same and they behave the same. We're examining in a setting of high illumination and the light source is very close to the eye, so pupils tend to react a lot and they all become small. And this leads to an underestimation of the power of a pinhole in those scenarios. So we have to train ourselves to examine with less light, even with the slit lamp turned off, so we can get a glimpse of the size of the pupil. We don't need very sophisticated equipment here to measure pupil size, but the cases where we have a larger pupil will obviously benefit more from this approach. So I'm sure some of you have witnessed this experience when we're trying to refract someone with irregular corneal astigmatism and we're having a hard time trying to find a decent refraction. And out of the blue, the patient says, oh, now I can see. And when you look up, there's a partial occlusion here of the lens, which is actually acting as a pinhole occluder. And that's when the patient gets excited and thinks that, oh, I want to do something like that. And you never find a correction that gives such a good vision. So this is another good point to consider when we are thinking about small aperture optics in cases of irregular corneal astigmatism. We have to make a distinction here of the preoperative pinhole acuity test. We should not totally rely on the pinhole acuity test by itself. Of course, this is quite obvious. We have to first try to find the best refraction to then add a pinhole on top of that best refraction, because here we are trying to separate the low order aberrations which are corrected by the refraction from the high order aberrations which can benefit from the pinhole occlusion. So this is an important take-home message when we're trying to find a good candidate. It's better to, of course, do the pinhole occlusion on top of the best refraction. And sometimes it's important to be aware of false positives. What I call false positives are those patients who really are excited with a pinhole occlusion test, but at the end we don't find a very good result with the implantation of a pinhole implant. And there are certain conditions here that I've had a difficult time to see this. I might think that this is a good candidate and the result was suboptimal. And the first scenario here, I would say it's those post-PK cases where you're left with a high cylinder. A high cylinder with some sort of irregular astigmatism mixed to it. So those patients can do really well with the pinhole occlusion, and you might think that this is enough. You don't have to consider treating the regular component of the astigmatism. And no, this is not the case. Those patients really depend on the correction of the regular component of the astigmatism. The pinhole effect might be able to neutralize a small amount of regular astigmatism. I would say around 2 diopters, or even less than that. But those high SIL patients, they need some sort of astigmatism correction, be in the cornea with a wedge resection or an arcuate incision, or inside the eye with a toric IOL. Usually it's, the toric IOLs do not reach such high magnitude of correction, so one might consider treating the cornea, the combinations of both, and then you'll be able to harvest the best benefit of the pinhole effect. Another important case are those cases where you're left with a high spherical error. So this is quite common in post-RK when we do cataract surgery, and for some reason we end up very under-corrected. So maybe because we got a false reading, a keratometry reading that was above what we considered, and we end up with a +8 refraction. And when we do a pinhole occlusion in this patient, we might think that this is the best case. No, this patient will not, the pinhole will not be able to neutralize this high hyperopia and give this patient a good visual rehabilitation. We need to approach this hyperopia even together or before, be it with an IOL exchange or some other sort of correction, to then apply the pinhole successfully. So be aware of those cases where you get a good pinhole acuity test, but present with this high hyperopia. Another important case, another important point is those patients where we see a central corneal opacity. So this is common in advanced keratoconus. This is even common in RK, where we're left with a subepithelial scarring and some other sort of scars. And we might get very excited with a preoperative pinhole acuity, but these patients will not reach very good vision. So it's better to do something in the cornea, try to get rid of this opacity, to then even consider it again if you're left with a high irregular astigmatism. But this is something important to take note. First, the best indication is for this combination of irregular astigmatism in a large pupil. And how large we're talking about? We're saying here anything around 4 millimeters in mesopic conditions are this is probably a good indication. But the indication should not rely only on pinhole acuity. You must take consideration of a slit lamp examination to see how clear the central cornea is, how large the pupil is, and how aberrated the cornea is. So I think we need to keep this informal, so if someone has any doubt and wanna ask questions, feel free to do that, because I think this is the best way to get the most out of this. All right, so now we're going to move to some more challenging cases. So this is a 55-year-old woman with this keratoconus in both eyes. She's been struggling with rigid contacts for a few decades now, and in the past 2 years, she just quit using them. She couldn't tolerate them. She had a significant astigmatism and a mean keratometry of around 55 in both eyes. The right eye was the worst eye here, with a thinner cornea and a worse, best corrected vision. So she couldn't see better than 20/60. So she was in trouble. She couldn't do much. And she had been consented for PK in her right eye. And this is when we considered a clear lens extraction in the right eye, followed by an IOL implantation and a primary piggyback of the pinhole. Interestingly, her IOL power calculation called for a negative power IOL. And we know all the challenges of IOL power calculations in compromised corneas. And we can't highlight enough the importance of trying to make the surface as best as possible and repeating multiple times the examination. But quite often, we're left with a very unpredictable result or unreliable result. So this was the case. We had a call for a negative IOL, and we weren't very confident about this result. So we decided to do something different here. Instead of using this pinhole implant as a piggyback implant, we did this clear lens extraction and implanted this sulcus device inside the capsular bag without any IOL, just by itself. So this is a very thin implant, and sometimes it can be challenging to use those flat injectors. So this is at the end of surgery, how the eye looked, with the capsular rhexis here overlapping all this occlusive portion. Here the post-operative image of the eye. And this is how the patient did after surgery. An amazing improvement. And we cannot highlight that this was not only caused by the pinhole itself. We know the benefit of the clear lens extraction in keratoconus or in cataract surgery. We very frequently we have a unexpectedly good result of a cataract surgery with a keratoconus like this. So this is the best way to get a wow factor at the end. It's when we can adequately combine a clear lens extraction or a cataract surgery and the pinhole implantation in the best candidates. So just to remind you, this is what she used to see before surgery. So she was thrilled, and she wanted to do the same thing in the fellow eye. So we were concerned about night vision. Will she report any sensation of dark vision or any trouble at night vision? Surprisingly, she said that the greatest benefit that she could note after surgery was at night, because that's when she had terrible glare, terrible stray light, and she was really bothered with all the small light sources that became really large because of this aberration. And she did not report any dark vision. So we went forward and we did the same thing in the fellow eye, which had a lower severity of keratoconus, but still very significant. And this is the result of the first eye, a very good uncorrected vision. And the fellow eye, which had a better keratoconus, ended up with a worse uncorrected vision. And this was not really any, here we used an IOL inside the capsular bag and the pinhole in the sulcus, but with a cylindrical correction, she could reach very decent vision, and she was happy. So this is another important take-home message. The pinhole implant will work the best when it's close to emmetropia. You don't want any sort of high magnitude refractive error because it'll need correction. And at the end, you can still provide her with glasses. We're talking about severe cases where glasses are on the table. I mean, they don't mind using glasses, but still we want to try the best. And this patient did very well at night. And she did report some changes here under low light. And this, she was very, she gave many details about this, and she sent me those pictures. She said that outside on sunshine, she couldn't really tell the difference between normal and how she feels now. But this is what she says, that before surgery, she would feel something like this. And after surgery, she could see a small reduction of luminance, or a small darkening sensation, which she believes was totally outweighed by the benefit of the visual improvement. So again, this is an excellent solution to consider in face of keratoconus. We know that refractive lens exchange by itself has been proposed as a method of correction of keratoconus in certain specific cases. And we had a good experience with the pinhole in pseudophakic eyes, so we felt that we needed to combine these two approaches into one. So I just want to share with you our results of a study where we included 85 eyes with keratoconus, in which this is the mean age. We're talking about a stable and documented stability, topographic stability on all those cases, and a visual acuity of not more than 20/60. 24 of these 85 eyes had already done a corneal cross-linking to make this, to halt the progression. And 30 of those eyes were consented for a PK. So we're talking about severe cases of patients who are indeed incapacitated. And this is a mean follow-up of more than 2 years. So it's a significant follow-up. And this is our result. So this is where we get the most out of it, is when we combine a correction of the low-order aberrations with a clear lens extraction or a cataract surgery plus the pinhole. We all know when we consider a clear lens extraction, we know what the main risk is. So when we take a look at just the reference here, we see that retinal detachment is the most important risk that we are considering here. And in this recent editorial, this is a really important opinion that was shared here, that in those eyes with a shorter axial length, the risk of retinal detachment is not that high as compared with eyes with myopia. Of course, we need a very detailed retinal exam before surgery with the help of a retina specialist. And we have to discuss this preoperatively. This is the mean axial length of these eyes that we included. And considering that in keratoconus we see a very deep anterior chamber, the axial length is would actually be shorter if these are the keratoconus is falsely giving a false impression of a longer axial length. But since we're talking about retina and retina detachment, another important issue is how we're going to examine those patients after implantation. This is an important point. The material of this device has this really neat property of being transparent to infrared light. So using infrared equipment, such as this infrared imaging system for a slit lamp, we can see the toric marks behind the implant. And using an OCT, we can get a wide field infrared retina picture, which gives a good field of view in most cases. When we get a very good dilation after surgery, we can still perform indirect ophthalmoscopy beyond the occlusive portion. So we are talking here about a pupil size of more than 8-9 millimeter to get a good peripheral examination. But this is important to note that this is possible. And it might be useful in those cases where patient reports some floaters or some flashes, so it's important that you are able to examine the periphery. Another important point here is that the posterior face of this implant, here we can see the vaulted haptics, this is an important characteristic of sulcus lenses, but also this posterior face of the implant has this, the occlusive portion has this meniscus shape to avoid contact with the primary IOL. And this is very important when we have an autorefraction reading after implantation, because remember that autorefractors operate with infrared light, and the infrared light will go through this occlusive portion, and this meniscus will act as a lens to the autorefractor. So you will get a false reading because of that. So this is an important point. After implantation, you might get some really different or unexpected result from an autorefractor. This should be discarded because it's totally unreliable. So this is another important point. What's the ideal target for refraction in face of irregular corneal astigmatism? We always advise a -2 refraction at the end. Why is that? Because this refraction will give a very solid near vision. You're less likely to have problems with improper IOL calculation and end up undercorrected. So at the end, if things go wrong, you'll end up near plano. But most importantly, the -2 with a pinhole will not deteriorate distance vision so badly. So this patient will still be able to read something around 20/50, 20/60 uncorrected, and will benefit a lot with a pair of glasses with a negative small correction. So this is what we consider the ideal target refraction. And an important point is that autorefraction becomes non-reliable and that bilateral implantation is possible. It's important to highlight that the sensation of dark vision can occur in some patients, and it tends to improve over time. This is highly variable. Some patients will not report any darkening, even with bilateral implantation, while others might report some darkening even with one eye. So an important point here when we're talking about sulcus implantation, we know of the many complications that single-piece acrylic lens can cause when implanted in the sulcus. And this image shows the big difference here between a single-piece IOL on top and this sulcus implant. Here we can highlight the larger overall diameter, the angulation of the haptics, and also the haptic profile, where we see a much thinner haptic with a more rounded profile and very polished. So this will avoid UGG syndrome or any problems related to sulcus implantation. And at this point, I'd like to invite Dr. Liliana Werner to give a wonderful talk here about sulcus supplementary IOLs and the considerations that we need to have in this scenario. So thank you, Liliana, a lot for your presence. And,
Good afternoon, and thank you very much. I would like, first of all, to thank Drs. Trindade, all of them, for the opportunity to be here as a faculty of this course. And you have here my financial interest, my financial disclosures, and I do not have any financial interest in this presentation. So we are indeed going to be making some anatomical considerations for add-on IOLs and IOLs for the sulcus in general. So we are going to be talking about problems such as interlenticular opacification. Is there a material that's best suited for the sulcus? Is there a design that's best suited for the sulcus? We also be talking about the problem of pigmentary dispersion, and at the end I'm going to show you some data of cadaver eye studies we performed in our laboratory using add-on intraocular lenses. So let us start with interlenticular opacification, and this is the opacification of the opposing surfaces of pigback intraocular lenses. This led a few years ago to the explantation of many pairs of intraocular lenses, which were analyzed in our laboratory at the Moranai Center. But basically, in all of the cases, we had two hydrophobic acrylic lenses implanted inside of the capsular bag via a relatively small capsulorhexis. And also in all of the cases, there were ASCRS lenses. You know that the ASCRS material has some adhesive properties. So because of this pathogenesis, there are some surgical methods that were proposed to prevent the problem of interlenticular opacification. And we are going to be focusing on the second one. So you have the primary intraocular lens still inside of the capsular bag via relatively small capsulorhexis, but then you have the secondary or pigback or add-on intraocular lens in the sulcus. And you can see that in this configuration, any residual lens epithelial cells that are in the equatorial region of the capsular bag, they are going to be sequestered, and this material will not be able to grow inside of the interlenticular space. So what happens is that if you have this configuration, you not have interlenticular opacification. However, you really have to think about what intraocular lens you could put in the sulcus. So let us start by discussing about the material. Is there a suitable material for the sulcus, one that's better than the other? So just as a small background, we usually classify these materials as hydrophobic or hydrophilic according to the water content, but also you can measure these characteristics by using tests such as this, the contact angle in water. So as you can see, a hydrophobic surface will produce sharper angles of contact with the water, so the drop is going to stand up, as you can see here in this image. However, if you have a hydrophilic surface, there will be flatter angles of contact in water, so the drop is spreading out. So that's basically how you characterize those surfaces of intraocular lenses. And I would like to highlight this study by Dr. Mantak, where he wanted to compare the hydrophobic properties of different hydrophobic acrylic lenses in the market. So he measured the angle of contact in water of all of these lenses, first in the dry state, and then he put the lenses to hydrate in BSS at body temperature for different time points, and then he repeated the measurements. And what was very interesting is that in the dry state, all of the lenses are really hydrophobic. So you can see there in the graph that the contact angle is quite high. The line actually represents the contact angle for the PMMA material, which is also a hydrophobic acrylic material. So all the lenses hydrophobic. However, after hydration at different time points, there is a change in this property towards hydrophilicity, so the materials become less hydrophobic. So in his conclusion, he mentioned that hydrophobic acrylic IOLs all showed similar level of hydrophobicity in the dry state, but there is a change towards hydrophilicity after implantation, after hydration at body temperature. And there is ample literature describing hydrophobic acrylic lenses implanted in the eye as pigback lenses, not only hydrophobic acrylic lenses, but silicone lenses, which is also a hydrophobic material. And there is no particular problem related to the material. So the material does not appear to be a very fundamental factor. However, yes, the design, that's the basic factor, and you really need to pay attention to that. So there is a lot of literature about the single-piece hydrophobic acrylic lenses that when they are in the sulcus, this is not an appropriate fixation site for them because of the flexibility, thickness, and the bulk of those haptics. These lenses have square optic and haptic edges. Also, the side walls are unpolished, and that's done on purpose to prevent glare and this type of aberrations. These lenses usually they have a planar design, so they do not vault the optic posteriorly from the iris. And also the diameter is not enough. It's up to 13 millimeters, which may be too short for many eyes if the lens is in the sulcus. And if the haptics do not fully extend because they have low compression forces, the IOL is prone to decentration in larger eyes. So in our laboratory, we described different cases where the presence of such haptics in the ciliary sulcus caused all kinds of problems, such as pigmentary dispersion, uveitis, increased intraocular pressure, and bleeding. So you can see on the left side the transillumination defect. And then when you explant the lenses and you analyze the lenses, you can see this huge pigmentary dispersion on the surface of the IOL. And as you can see on the right, you have a scanning electrophotomicrograph of the side wall of this lens. So it's very unpolished, and you have these rough edges, and of course, the haptics are very thick. So we want to know a little bit more about this problem, and we received in our laboratory pseudofake human eyes obtained post-mortem, and these eyes had this type of single-piece intraocular lenses implanted, and we selected those with an asymmetric fixation of the IOL or with this type of IOL in the sulcus. So you can see in the central image, the haptic on the left side is actually in the sulcus, and on the right side is inside of the bag. If you analyze with techniques such as high-frequency ultrasound or MRI, you can see that this asymmetric configuration may lead to problems such as tilt, and also it may lead to some decentration of the lens. But very importantly, when you look at the histopathology of the side of the eye where the haptic is in the sulcus, you can see disruption of the pigmented layer of the iris. Whereas when you see the histopathology of the side with the loop appropriately placed in the bag, you can see that there is no disruption to the posterior surface of the iris. And also this same thing can happen with three-piece hydrophobic acrylic lenses. In case you have lenses with edges, they are also not polished with some rough lines, such as in this case we described. This three-piece hydrophobic acrylic lens was implanted as a piggyback lens, and it caused significant pigmentary dispersion, actually pigmentary glaucoma in this case, and you can see the significant pigmentary dispersion on the surface of the IOL. You can appreciate the side walls, they are not polished, the rough lines, etc. So there are some studies also showing pigmentary dispersion from sulcus fixation of three-piece lenses with a square edge on the anterior optic surface, and this is observed not only in cases of piggyback implantation, but sometimes also in primary sulcus fixation of these intraocular lenses. But there are some studies where this excessive interaction between the anterior square optic edge and the posterior iris surface was not really found, just a transient pigmentary dispersion. And another thing to keep in mind is that nowadays, in many cases, the surgeons are reserving the three-piece lenses for cases where there is some complication during surgery, so an intraocular lens cannot be fixated within the capsular bag. And of course, all of this pathology you see here cannot be just attributed to the IOL. There was some complicated surgery there too. But we wanted to know more about this problem, and we performed another study using pseudophakic human eyes obtained post-mortem. And in this case, we wanted to compare the pathology of having 3-piece foldable IOLs with square or round anterior optic edges and asymmetric fixation or a fixation in the sulcus. So we could collect some eyes from the eye banks, and we had 13 hydrophobic acrylic 3-piece square anterior and posterior optic edge IOLs. And then we compared this with a group of 14 3-piece IOLs with a round edge on the anterior optic surface. There were 13 silicone lenses and 1 hydrophobic acrylic lens. You can appreciate here in these scanning electrophotomicrographs the differences between round and square edges and polished edges and unpolished edges. So it was very interesting because in the eyes with the IOL having a square optic edge, not only on the posterior surface but also anterior surface, we had very significant findings such as a disruption of the posterior surface of the iris, the pigmentary layers. You had atrophy of the iris, you had thinning of the iris. You also had pigmentary dispersion everywhere in the eye. For example, on the capsular bag. And the most important finding is that we had a pigmentary dispersion within the trabecular meshwork in all of the eyes of this group. And this was observed just in one eye of the round edge group. So this really shows some constant trauma and rubbing of the IOL, of the posterior surface of the iris by the IOL. So the findings were more serious when you had anterior optic square edges. So what is appropriate for the sulcus then? First of all, posterior iris clearance, so you have to be away from the posterior surface of the iris. You can have IOLs with loops that are angulated posteriorly. The loop should be quite thin, smooth anterior surface, round, smooth, regular anterior optic edges, and the IOL should provide secure fixation in the sulcus, so the diameter is actually very important. Minimum optic diameter of 6 millimeters and minimum overall diameter of 13 millimeters. So here in the United States, there are some large diameter PMMA lenses for sulcus fixation. Until a few years ago, we had this 3-piece silicone lens, which is very smooth with anterior edges and had a large diameter, but unfortunately, it seems that that lens was discontinued, but it was a favorite for piggyback implantation in the US. And in other markets, you do have lenses that were specifically designed for sulcus fixation as piggyback intraocular lenses, such as the Sulcoflex, and I'm going to be talking a little bit about that design. But before I go there, just some reminders is that even for the sulcus fixation, you still have to have an appropriate capsular support. Otherwise, it's best to do some suturing to provide stabilization. And if you have a well-centered CCC, even if you have a posterior capsular rupture, and if the diameter is slightly smaller than the optic, you can perform optic capture and still appropriately fixate the IOL. You have to adjust the power of the IOL for the sulcus unless there is optic capture. So let us go back then to these add-on IOLs. I wanted to mention a little bit about the Sulcoflex. And what I would like to highlight in this slide is that this was a Sulcoflex lens that was explanted because of opacification. So the lens is made of a hydrophilic acrylic material and was calcified, so it needed to be explanted, but otherwise that was considered a very successful case. And what I want to highlight here is that when we look at the lens under the light microscope, you can see that there is some pigmentary dispersion in the haptics. So with add-on intraocular lenses, pigmentary dispersion is not going to really be zero, and you also can have some dispersion during the surgical procedure itself. So just to highlight this fact. We had the opportunity to analyze the design of the Sulcoflex lens in a cadaver eye study. And we had pseudophakic humanized obtained post-mortem with an IOL in the bag. The eyes had different sizes, were implanted with different lenses in the bag, had different amounts of summaries information. And what we did, we analyzed them with high-frequency ultrasound before and after add-on IOL implantation. And we also used some views like the Miyake view to analyze the fitting of the add-on intraocular lens. So this is just one of the examples. So you have here a cadaver eye with a single-piece hydrophobic acrylic lens in the bag. You can see on the left the lens is quite thin. And in this particular eye, there was pretty much no summaries information. So on the right, you see the implantation of the add-on lens. So you have a very good result with, I'll go back here. You have very good result with both IOLs centered and there is no tilt, and you can see an appropriate distance actually between both lenses because of the convex-concave configuration of the sulcal flex. So here you see the same eye from a posterior view, and because there is no summaries ring formation, you actually can see the loops of the sulcal flex going to the sulcus. So that's a beautiful result. In this second example, you have an eye implanted with a single-piece hydrophobic acrylic lens, but there is a lot of summaries information. So you have the eye before and after add-on implantation. Still, you have both lenses, they are centered, and there is no tilt, and there is less distance between the lenses, but you definitely do have a distance. So again, a beautiful result, and just for you to have an idea, this is the amount of summaries ring in that eye, and that's why you do not see the loops of the sulcal flex going to the sulcus. And in this last example, this was an eye implanted with a plate haptic silicone lens. And those lenses were made of old silicone material. The refractive index is very low, so the lens is usually very thick. So a very thick intraocular lens inside of the capsular bag. And after implantation of the sulcal flex, you still see both lenses centered, no tilt, less distance between the lenses, but still an appropriate distance because of the convex-concave configuration. So here you have the same case, and there was also some summaries ring, so you cannot really see the sulcal flex loops going to the ciliary sulcus. So the current design of the lens that's the subject of this instruction course, the extra focus, it's very similar to the sulcal flex design. So you have the open loop design, large diameter, you have the optic haptic angulation, and hydrophobic acrylic material is different because the sulcal flex is hydrophilic acrylic. Otherwise, you have many of the same characteristics, including the large diameter, thin haptics. But this is a design that actually evolved. So at the very beginning of this project, the design was like shown on the left. It was more like a tripod type of design with 3 closed loops. And then we had the opportunity to perform a cadaver eye study comparing both designs to see if the current design really have some platform advantages. So we did a similar studies with eyes having IOLs in the bag, different sizes, different amount of summaries information, and we analyzed the eyes with OCT, anterior segment OCT, before and after implantation of the lenses. For each eye, we would put both lenses, so we start in one eye with the old design and then the new design, and the next eye we would start with the new design and then the old design and perform the analysis. So you can see here some examples of the eyes we used in this study. So we had different size of eyes, different amounts of summaries information, lenses that were single-piece, hydrophobic acrylic, or 3-piece silicone, so platform lenses, so all kinds of lenses inside of the capsular bag. And then you can see here the eye before implantation of the add-on IOL. And then in this case, after implantation of the new design, so the lenses are centered, there is no tilt, there is an appropriate distance between the lenses. And then that was removed and the old design was placed. And then what you can see is that sometimes you analyze one meridian and everything looks fine, but then in another meridian, there is a slight tilt, but otherwise centered and with an appropriate distance between the lenses. In this other example, with a lot of Summers ring and a 3-piece silicone lens, again, you have, with the new design, the distance, centration, no tilt. And then with the old design, you have here, everything looks fine, but when you go to another meridian, you may see a slight tilt of one lens in relation to the other. And here's just to show you some anterior views that beautifully demonstrate the position of the loops in the ciliary sulcus for both of the designs, and you can see the primary IOL in the bag. And a posterior view would show more or less what's happening. So you can see here from posterior view the appropriate position of the loops of the add-on lens going to the ciliary sulcus. But with the tripod, it seems that sometimes if there is a small area with a fragility of the zonules, there is a little bit more chance for one of those closed loops to go through it, and then it's located in front of the ciliary processes, so you may have a slight tilt. So it's still centered, but you may have a slight tilt. So that was what was happening. So in conclusion, the current platform of the extra focus really apparently have all of these advantages. So it has a large optic diameter, and this is very good in reducing the risk of optic iris capture. It has the large diameter undulating haptics, which is very good to provide IOL centration and also rotational stability. Has a polished round edge, undulated haptics, and there is minimum tissue contact or reaction with the interaction with the posterior surface of the iris. The posterior optic haptic angulation also helps in this uveal clearance and decrease the risk also of optic iris capture. And finally, the optic configuration, it's really proven to be very useful, the concave convex configuration, because this is going to avoid contact between the two intraocular lenses, and this is going to decrease the likelihood of any induced refractive error or any induced optical aberrations, which had been described previously in the literature in relation to some piggyback intraocular lenses. So again, thank you very much for the invitation. Thank you for your attention, and I'll be very happy to answer any questions that you may have.
Thank you, Liliana, for this wonderful review of anatomy and pathology. So this is useful not only for this course, but for anyone who implants IOLs. So I'd like to, thank you very much. I'd like to invite now Dr. Sergio Quitco from Porto Alegre, Brazil. Sergio is an amazingly skilled corneal surgeon, and he will share his experience with pinhole optics in face of corneal pathology and where he believes this class of implants play a role.
I would like to thank Claudio Trindade for his kind invitation to share with you my small and initial experience with his invention, the extra focus implant. So I have no financial interest in this presentation. We deal with corneal pathology for a long time. So sometimes for irregular and asymmetric astigmatism, corneal irregularities, we can improve by performing topographic ablation, but that's not all cases that we succeed. Sometimes we try to adapt scleral lenses. Some patients tolerate, some don't. So the extra focus implant I found very useful for some of these cases. And my first implant was in this young female, 35 years old patient that had a severe alkali burn with paralytic mydriasis and intense photophobia, as you can see on the right-hand side. I performed first, of course, ocular surface surgery to try to improve corneal surface with a limbal autograft and amniotic membrane and transplantation. And then I called Claudio Trindade, and he was kind enough to send me some initial implants, some extra focus to try in some of my patients, and this was the very first. Then I did clear lens extraction. She didn't have cataract, but due to the intense photophobia, and I wanted to implant the extra focus, I removed the crystalline lens and primarily implanted the extra focus, and I performed a pupilloplasty due to the mydriasis. She had 20/80 vision. This was her topography. You can see a very irregular topography, and this is the implantation after the primary IOL implanted in the bag. This lens goes easily through a 2.2 incision. I use Monarch injector, but you can use many others. But I found to be easier with Monarch through a 2.2. The first case, I didn't try to implant the extra focus in the bag because it's really difficult. So we try to stay in the sulcus implantation, and then I performed the pupilloplasty because it was an inferior defect, and the patient had a lot of photophobia. And she was very, very happy. So my small experience is in 12 eyes, 5 post-corneal grafts and other causes. This is a patient, a colleague of ours, a pediatrician, that had urethrovalia after PKP for Fuchs dystrophy. He had already underwent a LASIK to try to decrease corneal astigmatism, but the astigmatism came back 5 diopters, so he didn't have enough tissue to redo photoablation, and then I performed an extra focus and an iris repair due to urethrovalia syndrome. And this is his post-op appearance, a 20/30 uncorrected VA, and a very happy patient. So this is the implant. As Claudio told us, it's not an IOL. It should be called implant because it's just an opening. Here you can see the corneal transplant of this colleague, this pediatrician, summarizing. He was already pseudophakic. So this is a very thin IOL. It's always good to have a backup implant just in case, but if you are delicate enough handling this lens, this implant, it's going to be okay, especially if you have already experience with the Socoflex implantation, because it's pretty similar. So this is another patient, also anesthesiologist, that had PKP bilaterally due to keratoconus. This is his left eye. He had already had several corneal surgeries to try to reduce his astigmatism, relaxing incision, compressive suture, topoguided trans-PRK, femto, arcuate keratotomy, and this was his last topography with a asymmetric and irregular cornea and a 2100 VA, corrected VA. So I implanted an extra focus. Here you can see the extra focus with a slight decentration, but that's okay. And this is the corneal transplantation. This is another patient of mine that had also urethrovalia after PKP for keratoconus, a young patient, 49 years old, businessman, that had a failed graft and intense photophobia due to the mydriasis. So he had a failed graft, so I regrafted him with a PKP. As you can see, I'm doing the implantation of the extra focus in an open sky surgery during the new PKP. To try to reduce his photophobia, you can see the iris sutures, the previous iris sutures. He had hand movement, and this is the post-op with 20/80 vision and great improvement, not only vision, but in his photophobia. Another interesting case is this lady had hyperopic LASIK for 7 diopters. So that's too much for LASIK, but we had some patients that were undergone to this procedure. I tried to improve her cornea doing wavefront guided LASIK and trans PRK and cross-linking, but she ended up with poor VA. And then I performed, when she developed cataract, a phaco plus IOL implantation and the extra focus. This is her cornea, corneal topography, and this is post-op with a 20/40 uncorrected VA, an excellent result, and she was very happy. This is another case of mine, very interesting, with a very keratoconus, a lawyer that could not tolerate rigid contact lens anymore. She couldn't tolerate scleral lenses. She had cataract and this important keratoconus with VA of 20/60 in one eye and 20/100 in the other eye. I went ahead and put a corneal ring, and this is the result after the corneal ring, reducing the keratoconus, but not improving too much her vision because she had already cataract. So I decided to perform her cataract implantation and primarily implant on the top of the first IOL the extra focus implant. Here you can see the ring, intrastromal corneal ring. It's a long ring, a 320-degree arc ring, and here with the extra focus implantation primarily. So this is the result I did in both eyes. So she ended up with 20/20 in one eye, -3, and the other plano 20/25, and a very happy patient. This is another interesting case that we can use extra focal for post-RK patients. This patient had an RK done previously for -7, and now the patient was +7.5 with this irregular topography and with a 20/80 vision. Of course, we can try to adapt contact lenses, go for a corneal transplant, but if we can solve this problem without touching the cornea, that's it's going to be much better. So this patient had a cataract, so I implanted with the phaco the extra focus primarily. Here you can see opening one of the radial incision, even with a 2.2 millimeter incision, but that's no problem. We can suture easily. And this is the extra focus being implanted on the top of the primary in the bag IOL. So here you can see also the RK incisions. And we have to finish the surgery with the extra focus centered. Sometimes it's not so easy, but almost all times we can get. And she had a great improvement. And the last patient I want to show is this one that also had +7 and underwent to a thermokeratoplasty in the past and ended up with a poor vision, 20/60, with a low quality vision. This is the topography. You can see irregular topography. This is post-op. She improved from 20/60 to 20/25 VA, and this is the surgery. You can see the scars from the thermokeratoplasty performed in the past. This was also a cataract patient, so I performed cataract surgery, IOL implantation, and the extra focus primarily right after implanting the first IOL. So one problem we can have is the extra focus decentration. Of course, this on the left is what you want, but sometimes you have this type of dislocation and you have to go back to OR and try to recenter the lens. And we might try to implant extra focus always in the bag, but it's not always possible. It's difficult to see the capsular axis, but when you can I think it's a good idea to try to implant like this, the extra focus inside the bag with the other IOL. Even with Trypan Blue, sometimes it's very hard to see the capsular axis edge because the extra focus is black. But whenever possible, I think this might decrease the rate of decentration. So now I'm trying to implant inside the bag. It's tougher because it's hard to see, but sometimes it's possible. Okay, so to summarize, I think this is an excellent invention. Congratulations. And it's an excellent choice for patients with irregular astigmatism. But as Claudio pointed out, the patient has to have a clear cornea. One of my patients had a corneal scar, a paracentral corneal scar. It was not central. With irregular astigmatism, I implanted the extra focus and it didn't improve the VA. So the cornea needs to be clear. So thank you very much for your kind attention.
Thank you very much, Sergio. Now I'd like to invite Dr. Roger Zaldivar, Jr. And while we change computers here, if anyone has any questions, it would be a good time to ask.
The difficulties to implant the lens in the bag is because of the size or because of the view?
Oh, perfect. Amazing.
Okay.
Sorry.
And otherwise, you recommend that it can be implanted in the bag?
Well, whenever possible, I think in the bag will guarantee a better long-term stability in terms of centration. We know that sulcus IOLs are prone to slight decentrations over time. So whenever this is being considered during cataract surgery, I think it's easier and better to implant it together with the IOL inside the capsular bag.
And another thing, how do you get this lens? Where do you buy it?
Well,
you have to buy it directly from Germany?
Well, this is being marketed in Europe and some other countries, and it's directly with Morcher in Germany.
Thank you.
And I don't know if probably you will talk about this later, but is it possible to have your view about the comparison between the IC8 and the extra? You are going to talk, because I had some experience with the IC8 and I have a patient next week and I'm not sure which one is the best. So
great.
Glad to hear it.
Thank you, Claudio. Thank you for putting together this great agenda. It's always a pleasure to speak after great speakers like today. And what I'm going to do mainly, I'm going to share my experience and my father's experience that is here with us regarding these small aperture IOLs. So, sorry, I'm going to jump here. So these are my financial disclosure. I do have some financial disclosure with AcuFocus. I've been working with small aperture with them since they launched the famous camera in the cornea, but now they jump completely to the back of the eye, which I think is a good idea. But let me start with the introduction of something that we are working, and it's the term optimized patient. Instead of the typical happy patient, we want to jump to something, say, optimized. What is an optimized patient? It's a patient where we do use the best available technology, where we fulfill patients' expectations of improvement, of course, taking into account the lifestyle and, of course, the clinical status. Why I'm saying this? Because today we have so many IOLs, and the easiest thing is to decrease patient expectation and put a monofocal. On the opposite, I think that we should take the advantage of what we have today with the toolbox that we have today and really try to create value and put the best technology available in each case, to tailor-made each case. In order to do this, you need to really adjust the treatment and create a tailor-made treatment. So what are we doing in aberrated corneas? What are we doing? Are we just going to the easy one, that is put a monofocal, or are we just trying to get advantage of the technology that we have today and try to upgrade this patient to improve the optical quality? So we all know, and I don't want to spend a lot of time, it has been mentioned, the role of the apertures to increase Of course, depth of focus and depth of field. I don't want to spend a lot of time on this, but of course, there's no free lunch. If you decrease the aperture, you will, of course, create a little bit more of diffraction. So there is the balance that we need to assess in order to see which is a good candidate and which is not. It's not all of them will be great or none of them will. No, we need to spend some time and understand which is a great candidate. So why? Because as I mentioned before, the smaller the aperture, the more the diffraction in the back of the eye, which means that they will decrease the contrast sensitivity and might create some issues at night if they are not the appropriate candidate. So this is what I want to make emphasize today on the numbers that I'm going to show. But there is always a balance on this. So let's jump a little bit with aberrations. In a very aberrated cornea, we know that if we have a big pupil, it's a mess, it's a disaster. So here, these are the best patients because they truly improve a lot their optical quality. If patients don't have aberrations in the cornea and have very small pupil, diffraction will be more dominant and they will be really annoyed. So the ideal is to have aberrated cornea so that they can truly be happy after the procedure and see an advantage. So it has been shown that this works great in all this type of irregular astigmatism. I couldn't agree more with everything that what you said, and I learned a lot from, of course, from your talk. And in our experience, the best patients of all so far have been the ones that have RKs, because they have a double effect. They have the effect of most of the times RK have some irregular astigmatism, and at the same time they block this photopsia created by the incisions. So let's go to your point. We have two small aperture IOL available today. One that includes power, and the other one that has been widely discussed today that sits in the sulcus. Which are the differences and what do we do in each, which is the strategy? So both of them, they are not treating astigmatism. They are compensating astigmatism by decreasing the aperture. What do I do when we have high astigmatism that we see has some sort of regularity that will improve with the toric IOL? We put a toric IOL and the sulcus and the extra focus over. The ICA doesn't have toricity, so that's something that is one of the things that we decide more. So something that I would like to talk, and perhaps we can exchange some thoughts. You mentioned that your spherical target was -2. Well, in our experience with the camera that has a very similar aperture, that the aperture of the camera was 1.36, this is 1.3, that's a slight difference. Our sweet spot was 0.75 -1. Why? Because that was what we expected, that the patient had the best balance from far and near. They were the most patients around 2020, 2025, 2030. They were really doing very good. If you go more myop, of course they were going to see much better for near, but they lose more for far. That's the balance. The IC8, it's hydrophobic. It has 1.36 millimeters of aperture. It has 3.23 in the total diameter, and that's one of the differences. And this difference I want to highlight it because I truly believe that the extra focus is the best by far for aberrations, by far. I have my experience, and Roberto can tell something, in patients that have no aberrations, I wouldn't recommend it, honestly. If they don't have aberrations, just for presbyopia, it's more difficult. You have to spend much more time because the trade-off is bigger. I love the extra focus for that. And the IC8 might work better for presbyopia because you have more light passing through the periphery, and it's a little bit different in that behavior. And that's what I wanted to share. Of course, I'm going to share some cases with the extra focus that I love it too. But this is a case, for example, with bioptics done in '99 with my father. And you can see he has one diopter of astigmatism against the rule, irregularity there, and you have there the myopic profile. And the other eye is the left one. The dominant eye is the left eye. non-dominant, and something important when you play with presbyopia is assess if they have binocularity. Because many times we infer, okay, I'm just going to leave this myop and put this extra focus to make him read from near, and then they suppress that eye, and you did everything in vain. So it's important to assess if that patient with that anisometropia that you can tell by the profile has the ability to read from near. So this is what happened. This is just going to go fast, but mostly what I did is I took away the ICL, yes, with my standard technique. Okay, let me see. Sorry, I was there. Okay, I took the away, I grab it from the center of the optic, from the shoulder, and you just pull it out. Very easy, very straightforward. I don't want to bother you with all the procedure. So at the end, what we did, okay, is we put the lens that it's a bigger incision, 3.5, and sometimes bigger, something that they need to work on, much bigger incision, but at the end it's pretty acceptable and it goes directly to the back. So I think that both technologies are completely complementary. It's a field that is growing and it's making everything for us much easier. I think they are going to be brothers. It's the extra focus and the IC8. I'm convinced that you must have both at your toolbox. So that's easy, very nice. And this is how you can see it with intraocular OCT. You can see it perfectly there. That's the position. And the results were very nice. And true, honestly, results are very impressive when you hit target. And that's another thing that we want to spend some time. But as you can see here, this is far monocular, and they were doing 20/20 in that eye with that astigmatism, with everything. And this is the defocus curve in intermediate. Whoever has done some small aperture knows that you are elongating the retina at the retinal image. You have an elongated image. Same happened with the good patients that we have in a couple of years ago with camera. You just get the target further and it's exactly the same. It's very, very good performance for intermediate. And let's just jump to the extra focus. It has been widely described today, but I want something interesting. Psychiatrist, I want to share this case. You've seen this before. 20/50 both eyes, and with pinhole, he get to 20/25 with pinhole. So I said, okay, let's go, and of course, let's do in the non-dominant eye, in the worst eye, let's do an extra focus. And very, very special guy, like every psychiatry, a little bit crazy, very obsessive. He came, he described me, he drawings and all, very, very special. And the surgery was amazing. Nothing special. We did do, in this case, the limbal relaxing incision. Nothing special of the procedure, only everything went perfect. This particular case, you will see now, it's fixed there. You see there, it sticks a little bit and I touch it, but nothing special, very nice. Very nice procedure. The interesting thing is that it happened to me like exactly the same like what you told. He came the other day, 1 month after, and said, please do it in the other eye. So this is one of the patients that we have with binocular implantation of this, and he's extremely happy. And you can see, you can tell those aberrations, how they look like, and those epithelial, those ingrowth in the incisions. So just to go to some numbers, the most interesting thing of all, for me, is what is the efficacy and the efficiency. To go to the most important slide is this one. On average, they win four lines. So they truly get the win, the efficacy and the efficiency. They are winning 4 lines with the procedure. And I think that's extremely important for us today. Is the #1 solution for patients with RK. Of course, not every RK, not a 4 incision RK with huge optical zone, but every RK where you truly see that the optical zone it has an invasion. We are very aggressive, and we suggest doing this extra focus to all of them. And I'm encouraging Claudio with enhancing a little bit the size for having other alternatives. I'm a believer in the small aperture technology, and I think in the future what will happen is you are going to customize each patient with their own aberrations and with their own asphericity. So same as we do today with corneal power, with the power of the IOL, I will see a patient, I will say, okay, he has this negative spherical aberration because of a hyperplate cornea. I don't need to go to 1.3. I'm going to put a 1.5, 1.6. So there will be a rule, and then we will customize each one. But I'm convinced that the small aperture technology is here to stay, and I think that it's our responsibility to create this value for the patient and assume this responsibility and to create maximum value. So thank you, Claudio, for creating solutions for us. I'm very happy to share our experience with you. Thank you very much.
Thank you, Roger. That was amazing. And we're running a little late here. We still have 5 minutes. So yes, you, Bruno, could come up just to share one last thought. And while he sets up, my opinion about the difference and when to use each, I think both are very similar in terms of principle. The power range of the IC8 might play a role here because it goes from 15 to 27, and when you have keratoconus, you usually use a low power IOL, so this might be important. And with RK, it's usually the reverse. You might end up with a high-powered IOL at 30 or even higher than that. So this is important. You might need a piggyback in the Sulcaflex, an IOL to treat that if you're considering the IC8. And the incision size here, which the IC8 requires a little larger. One great benefit of the IC8 is that you can examine the retina easier because of the outer transparent area. So, and the sulcus piggyback implant has the benefit of being able to use it primarily or secondarily. Sometimes we have surprisingly good results with conventional cataract surgery in cases of irregular astigmatism. So it might be better to go just with regular cataract surgery and then, if necessarily, do the pinhole implantation.
Okay, so I'll just talk about briefly about a case where I think it has a lesson behind it, and in which we're pretty much expanding the use of this technology, combining it with a different surgery as well. So basically we do mostly cornea surgeries, and I think everyone in this room who has done any corneal transplant agree with me is that we need to fear open sky surgery. And for many other reasons, we also fear sutures as well. So we're pretty much convinced by the superiority of DMAC when treating failed previous penetrating grafts. However, this approach might not be appropriate when we're dealing with irregular corneas. So I'd like to share this very brief case. This is a 62-year-old lady who had a penetrating keratoplasty done in the 80s to treat her keratoconus. But unfortunately, she never saw much benefit from this surgery because of residual corneal astigmatism. But she does notice, however, a further deterioration on her vision more recently that has been attributed to a dense cataract in a late graft failure. And in this sort of scenario, the obvious approach would have been to do the cataract surgery combined with a repeat PK. But with the use of small aperture optics, we thought we could expose this patient to a far less risky procedure. So we thought about killing the aberrations with the pinhole and the irregular astigmatism with the pinhole, and combining that with DMAC to restore the transparency of her old graft. So that's what we did. And in this case, as has been presented here before, we decided to implant the pinhole by itself inside the capsular bag, since IOL power calculation called for a negative power lens. So as you can see, a very dense cataract, so we took care of that. And we implanted the pinhole, again, inside the capsular bag as a sole implant, no IOL here. So we did that to leave the ciliary sulcus opened in case we needed an IOL in the future. And then we did normal DMAC as we would do in these post-BK cases. And 5 days later, this patient came back with a pretty large graft detachment, which has been reported in the literature, and we had to rebubble her, and that's how we'd like to do these cases under the operating microscope. And 3 months later, we can see a very well-centered pinhole with a fully attached graft. And her vision has improved significantly to 20/40, and she was very happy, very excited. And 1 year later, we can see the cornea clarity completely restored, and again, a very well-centered pinhole. And we can appreciate a sustained improvement in her vision. And note that the final refraction spherical equivalent was pretty close to plano. So in this scenario, an IOL was actually never needed. We published this case in the Orange Journal last year. So to conclude this, we believe that EK, in our opinion, EK is the preferable technique for treating failed penetrating grafts. And the use of an intraocular pinhole may expand this benefits even to irregular grafts. So I guess this is the lesson here is that combining two different technologies, two different procedures might, they might improve it both sides even more. So I guess for the sake of time, I'll stop my presentation here and happy to answer any questions if there's any. Thank you.
Thank you. Thank you. Yeah, and I think we still have a few minutes for some questions if anyone has them. Yes?
Is there any chance of getting this in the U.S.?
Well, Morture does have plans for an FDA trial for next year, but it'll take a while, I guess. I wouldn't be very optimistic about that.
Sorry. Congratulations for the course. And do you think that when using the extra focus, when planning the extra focus, using pilocarpine before the surgery can be a predictive test also for disturbances? Because a patient of mine that I recently operated said to me that pilocarpine was not good for him. He was a flight pilot, and so he didn't want too much dark, and he didn't want pilocarpine. So in my opinion, if a patient doesn't want pilocarpine, extra focus probably is not the best choice, and IC8 might be a better one to give some more light.
Absolutely.
Does this make sense?
Yes, it does make sense. The only exception to that would be when you're considering cataract surgery together with it, and then you're going to change the refractive error of it. So it won't be a fair simulation. But if the patient is pseudophakic and you're considering a secondary implantation, then it's absolutely recommended to do a trial of pilocarpine.
This patient is a 53-year-old man, so a very early cataract, not so much.
But he's close to plano, because sometimes those post-RK are very hyperopic.
And in the first eye, I implanted an IC8, and the day after, he was 20/20, he was able to see the first, he was very, very happy, but he was still able to see some halos at night because the ring is small, it's just 3 millimeters.
3.6, yes.
So I was wondering whether in the second eye, going to an extra focus, even if he does not like pilocarpine. So I think I will go to IC8, just because he doesn't like too much dark. But
Yeah, I just wouldn't be very convinced about the difference in darkness unless the pupil dilates really much larger, because it's 3.6. So you get a really rim of of outer light, that could be
The
useful.
pupil goes to 6 millimeters.
So that might be an important difference. So maybe it's a good. Yeah, I wouldn't do any pinhole implant if patient doesn't like pilocarpine at all. So regardless of which version, this should be a concern.
Okay.
But yes.
Thank you. Thank you.
I hope it's useful.
Have you used the capsular axis to capture the lens and have better centration when you use the sulcus?
Well, we've tried to do that. It's not that easy because of the vault. So no, sometimes we just place it in the bag together with the IOL when we are considering centration. And this is what we actually advise. And this is one thing that Dr. Mike Snyder, who started doing artificial iris in the sulcus, he ended up migrating to the bag. It makes sense for us too. So whenever possible, an in-the-bag implantation together with an IOL, we have a fairly large follow-up to that, and it's been terrific. So I think this is more advisable.
Okay, thank you.
Any recommendation with the YAG, with yagging?
Pretty much a regular YAG. It's hard to aim because when we have an irregular cornea, the aiming beam is, you get a lot of reflection. So just maybe a contact lens for a YAG procedure would be reasonable just to avoid pits or something like that. But you can still shoot through the pinhole with no difficulty, and you can ask the patient to move sideways, and you can actually open pretty much a wider aperture there. But it's a routine YAG.
Yeah, I think
Before the YAG, we
there's a
use
point
a
of
bend
prophylactic
needle.
performing the YAG.
Through the before the
Some patients that I think YAG is going to be difficult, like do
Prophylactic, yeah.
primary capsulotomy.
Yeah,
very small,
it's,
because you need only a very small capsulotomy, only
You're right.
2 millimeters is enough. Because
Yes.
the aperture is very
yes,
small.
yeah,
That you just cut the center and that's all.
yeah. That's wise too.
I think
Any patient that needed retinal surgery?
I did have one who developed a retinal detachment a year and a half later, and 6 months before that she had a retinal detachment in the fellow eye, which was unoperated. And so this is a hard case which developed a bilateral retinal detachment. And the eye that was operated, we could dilate it further from the aperture. We could see the detachment, and we immediately explanted and referred to the retinal surgeon. Yes, yes. Yeah. It's very easy to explain.
You mentioned the case where you put the IOL, just that IOL in the bag, right? How is it
Yes.
behaving in terms of PCO and fibrosis of the rexes and everything? Just that IOL.
that's a good question. We in fact have probably around more than 5 patients who have the pinhole IOL as a solo implant in the bag, and we can see a probably earlier rate of posterior capsular opacification. But aside from that, we can do YAG laser in those patients, and it does behave pretty much standard.
And there is
Yeah.
no case of contraction of the rexes?
Not that we've noticed. No, none of our patients did. The- Correct. Correct.
Not
And
resist, yeah.
and one question I probably have to you as well is, what is your opinion in regards to the flow of aqueous, if there's any, through the pinhole if we put this IOL as a sole implant in the bag? I mean, does it exist? Do you feel that it might exist? Do you feel that it might contribute to that? Because our experience has been that capsular rexes, they don't behave any different than what we would expect with a normal IOL in the bag. But the posterior capsule does tend to opacify a little earlier.
Maybe because you have the concave surface on the posterior side.
Exactly.
right?
We don't have contact. Exactly.
In the first slide, you mentioned that this can be useful for multifocal IOS. Do you mean
Yes.
just like a multifocal IOL, or to treat complaints due to?
That's exactly what we meant. Patients who complain of glare and halos after multifocal IOL, we have 3 cases where we used, and also Dr. Medina here has a series of few who he's used successfully for that reason. We might consider this on those cases where we've done a YAG capsulotomy and an IOL exchange would be risky. And we were able to pretty much treat those symptoms completely with high patient satisfaction. And this is where a trial of pilocarpine will give a really good
and do they lose multifocality?
No, they remain with a very decent uncorrected vision for both distance and near. So this might be an interesting, we have a paper being presented on this specific application tomorrow, I think, tomorrow. Yeah. Yes. So we had this prepared for this, but we ran a little late.
So they could also be useful for negative dysphotopsia.
Well, for negative dysphotopsia, we're not very sure. We don't have any experience with that. We don't truly believe this because negative dysphotopsia might improve with mydriasis. But maybe one of the solutions proposed to negative dysphotopsia is any piggyback IOL, so this might be the case. We don't have this answer yet.
Thank you again.
Thank you. So this, I guess, concludes this course. Thank you very much.